What does browser-based access provide us? We enable the user to authenticate to those websites without you needing to manage a DMZ or internet edge. Provides access without need for a VPN or that client software to be installed, and provides the same user experience as if the user was accessing that website directly. The websites can reside anywhere, whether they're in the physical data center or in infrastructure as a service, and we're then able to do app protection to protect that website from the OWASP top 10 and custom signatures and inspect that content. And the ZTNA policy, it provides least privileged access. So the browser-based access ensures that the user has authenticated into the Zero Trust Exchange that allows us to apply policy and then segment and provide access through the app connector to the application. A user portal provides a graphical view within the browser of those browser-based access applications that the user has access to. So use cases mean that we can immediately provide day one access for subsidiaries or acquisitions or partners to access applications. We can provide limited access to suppliers, contractors, customers, and other third parties through this mechanism, again, without the need for them to install a client connector software. And so this also supports a BYOD initiative. Your users can access your corporate resources over HTTP and HTTPS on their own devices, again, without them needing to install the client connector and also without them needing to have their device necessarily managed by your MDM solutions. Again, this comes down to the trust of the users and the risk associated with accessing those applications without a client-based endpoint solution. So how does this work? The user types in the URL of that application that hits the Zero Trust Exchange and they're redirected to your SAML IDP for authentication. The user authenticates against the SAML IDP, they're redirected back to the Zero Trust Exchange. We consume that and the user then gets a TLS connection to the Zero Trust Exchange. We identify the application in the data center or infrastructure as a service behind the app connector, and the app connector establishes its connection over TLS to the cloud. And the cloud then stitches those two connections together to provide the user connectivity through the Zero Trust Exchange to the application using the browser. And of course, real-time and global visibility into all of their application traffic exists because the Zero Trust Exchange is providing that continuity and that logging of the traffic. So let's understand a bit about the way those TLS connections are established. So once the user is authenticated to the Zero Trust Exchange, there is a connection between the user's browser and the Zero Trust Exchange. There's a client hello, there's a server hello, there's a server certificate that is provided to the client. And so it's important that the client trusts that server certificate. And so that might be publicly signed by a public certificate authority like a VeriSign, or it could be your internal certificate authority where only your internal clients trust that root certificate authority. Once the user's got that connection to the Zero Trust Exchange and the policy permits them access, there is a tunnel created inside out between the app connector and the Zero Trust Exchange. So the same Zero Trust tunnel. And then through that Zero Trust tunnel, there is a connection from the Zero Trust Exchange through to the private application through the app connector. So in essence, we have three tunnels: the client to the Zero Trust Exchange, app connected to the Zero Trust Exchange, and Zero Trust Exchange to the application through the app connector. It's also worth noting that the connection from the Zero Trust Exchange to the application could be HTTP through that ZPA tunnel, so the ZPA tunnel is providing that secure transport. So let's think about those certificates and how we get those configured. So you need to be able to load the certificate into the Zero Trust platform. So we go to the ZPA administration platform, certificate management and certificates, and we can generate a certificate signing request there, input the subject fields, the subject alternative name, download that CSR and then have it signed by a certificate authority. Again, either your internal CA or an external CA, and then upload that certificate to the administration portal. It's important to realize at that point that the private key has never left the Zscaler cloud. Alternatively, you can take your existing certificate, export the certificate and private key, concatenate them into a single file, and then upload that certificate and private key to the platform. So that is an alternative approach, but of course that means you're exporting the private key from your web server and uploading it to Zscaler. So we create our application segment, we select browser access, we define the application as being HTTP or HTTPS in the back end and what port that is listening on. And then we map it to a internet-facing web server certificate. If the internal web server is running on HTTPS and it's using an internally signed certificate authority, then we need to tick the Use Untrusted Certificates. This ensures that Zscaler bypasses any of the certificate warnings between the Zero Trust Exchange and the application. We can also enable inspection to do OWASP Top 10 and custom signature inspection of the HTTP payload. Once you've created the application, we're then going to be provided with a CNAME, and you create that CNAME in your internet-facing DNS to enable the user to be able to resolve and route to it. You're going to create that public DNS entry with that CNAME that's been provided and enable the user to resolve it and route to it. So at this point, applications can be accessed directly by their FQDN. I open my web browser, I enter the FQDN, I'll be redirected to the IDP, authenticated, redirected back to the Zero Trust Exchange, and then that website will be displayed. If we think about third parties, they may not know about what applications are available. So we have the user portal. The user portal provides a set of tiles showing which applications the user is permitted to access. So the user enters the user portal URL and they're redirected to the IDP. Again, they authenticate to the IDP, they redirect back to the Zero Trust Exchange, and the user portal displays the private applications the user is authorized to see. The user would then click one of those applications, which will follow the link, and then they go through the same process as browser-based access to identify the application, create those tunnels, stitch those tunnels together, and provide connectivity through the Zero Trust Exchange to that web-based application. So to do this, we need to create the user portal and then link the applications into the user portal. So again, we have to upload a server certificate for that portal, or you could have used a wildcard certificate. You create the user portal, we provide a user portal URL, and then we create portal links to link applications into that portal. The portal links could be private applications, which are already defined, or they could be public applications where I create a free-form link and provide access to that. So I might have salesforce.com in there and want to be able to provide a link directly to my Salesforce instance within that user portal. In addition to the user portal and browser-based access where the user is accessing the application directly, we have the ability to do isolation. So isolation creates a containerized browser which provides a virtual air gap between the end user and the application they're accessing. So they never interact directly from their browser with the application. They get the pixels screen scraped down to the user's device via an HTML5 stream, and any clicks or keystrokes are then replicated back to that containerized browser and then pushed into the application. This air gap prevents data loss, so the user cannot copy and paste or download content from that private website. It also means that any infections on the user's machine don't pass through to the application. So we're providing both data protection as well as application protection. And this can then be layered on top with the inspection capability of the private app protection to scan for the OWASP Top 10 and custom signatures. So browser isolation is fully integrated with the ZPA browser-based access and B2B framework. It's a granular framework for defining who should be isolated in what criteria and clear policies for what applications are reachable from the isolated browser. So I can enforce exfiltration controls in terms of allowing copy and paste, upload, download, printing, and that read-only isolation capability, as well as which regions the isolation is going to run in.